Okay, section 1.2 is about quadratic equations, and these are equations that look like this. ax squared plus bx plus c equals 0, where a, b, and c are some numbers. I want to talk about how to solve them. How to solve them kind of depends on the way the problem is given. Like the absolute easiest way to solve a quadratic equation depends on how it's given to me, but if it's given to me in this form, this is the easiest kind of quadratic equation to solve. It doesn't look directly like ax squared plus bx plus c, but if you FOILed this out and brought the 36 over here, there'd be a constant term in there you could combine with the 36, and this would look like ax squared plus bx plus c equals 0. But rather than make this one look like that, I'm grateful that it looks the way it does, because all that's happening to x, it only appears one time in this equation. Some stuff is happening to it in sequence, but I can undo those things one step at a time and learn what x is. Like I can undo that squaring. What would undo the squaring here? What should I do to both sides of the equation? Well, take square roots. I have to be careful about this, so think about it. This says x minus 9 is a number so that when you square it, you get 36. How many numbers are there like that? There are 2. There's plus or minus 6. Right? Either one of these, when squared, would give me 36. But those are the only numbers whose square is 36. So x minus 9 is 6 or negative 6. Usually we write that like this. X minus 9 is plus or minus 6. So here's a warning. When taking the square root of both sides of an equation, don't forget the plus minus. But now let's finish solving for x. I'll just add 9 to both sides. So x is 9 plus or minus 6. That is, x is 9 plus 6 is 15, or 9 minus 6 is 3. But usually in quadratic equations, I'm not so lucky that the x appears just like this, underneath a square, and that's it. Usually there's x's appearing in a couple of places in the equation. So what I generally try to do is get a 0 on one side and try to factor the other. Let's say in this problem, I've already got a 0 on one side, but I could collect up terms, bring stuff over to the other side so there's a 0 on one side, and try to factor the other. Do you see how it factors? You could use backwards FOIL. That's x plus 2 times x plus 1. Now a 0 over here is really important for this next step, because 0 has a special property. If two numbers multiply to give you 0, one or the other had to be 0. That's not true if this is a 1 or a negative 3 or pi or anything. It's only 0 that's got that property. So I'll repeat it. If the product of some numbers equals 0, then one or the other number had to equal 0. So I conclude from this equation that x plus 2 has to be 0, or x plus 1 has to be 0. And these are easy to solve. I'll subtract 2 from both sides, x is negative 2. I'll subtract 1 from both sides, x is negative 1. If the equation doesn't appear to me like this, or if it appears like this and I tried to factor but failed, then I can always fall back on the quadratic equation. I beg your pardon, quadratic formula. It says, if ax squared plus bx plus c equals 0, then x must be negative b plus or minus the square root of b squared minus 4ac over 2a. Well, why don't I use that on every problem? Well, some problems are easier to solve without the quadratic formula. I think 1 and 2 are probably easier than plugging in these numbers. Also, I've noticed that when, say, I give my students a problem that requires the quadratic formula, and let's say 20 of them attempt to do it, maybe 5 out of 20 or more will make a mistake in doing it. So the quadratic formula is kind of error-prone. I mean, I would avoid using the quadratic formula if there's an easier way to do the problem, simply because I don't want to run the risk of making an arithmetic error in my solution. So let's try an example using the quadratic formula. Hey, I notice I can factor this side. Does that help? No, because there's not a 0 on the other side. It doesn't do any good to factor x squared minus 5x if it doesn't equal 0. So how do we get a 0 on this side? By subtracting 2 from both sides. Now, I try to factor that using backwards FOIL. I don't have a lot of choices about the numbers involved, and I tried and failed. I wasn't able to factor that. So instead, I'll use the quadratic formula. So that says the solution must be x equals, let's see, a is the x squared coefficient. That's 1. B is the coefficient of x. That's negative 5. And c is the constant term. That's negative 2. So it's negative b plus or minus the square root of b squared minus 4ac over 2a. That's 5 plus or minus the square root of 25 plus 8 over 2. That's 5 plus or minus the square root of 33 over 2. That's really two numbers. It's perfectly acceptable to write it that way, but if it will help, I'll tell you that means x is 5 plus the square root of 33 over 2, or 5 minus the square root of 33 over 2. This thing in the quadratic formula that appears under the radical, the b squared minus 4ac, is called the discriminant, because when the discriminant is positive, like in this last example, then you can take the square root of any positive number and you get these two different solutions. That is, when b squared minus 4ac is positive, that means there are going to be two real solutions to the quadratic equation. But if it equals 0, what will happen then is the thing under the radical is 0. So for instance, in this problem, I would have had 5 plus or minus 0 over 2. Well, 5 plus 0 and 5 minus 0 were the same thing. So you only get one real solution. What happens if that discriminant, the thing under the radical, is negative? What if this had been the square root of negative 33? Well, I can't take the square root of negative 33, or any negative number for that matter. So when the discriminant turns out to be negative, that means there are no real solutions.